Welcome everyone. It's that time of the year and we are in festive tech calendar days for December 2025. I'm your host Konstantinos and together we're going to explore machine learning AutoML, an end-to-end web app with AutoML and Azure OpenAI. Thank you everyone for joining wherever you are and let's jump into it. So for those that you already know me, you probably know that I'm not into presentations and I prefer, the demo part. But let's have a quick look to understand what is going on with our project today. So this is a project that is evolving and currently we're in a very, very good stage. The project offers us the capability to upload car details with some specific fields that define the price of a car, the most important factors, and we have pre-trained a model that predicts the price of this used car. We're going to see everything from the training of the model up to publishing it into an endpoint and then consuming it through this web app where we can upload new cars and get estimates. And not only estimates, we're throwing OpenAI GPT-4o Mini to get a quick summary of the car that we are browsing because we also have a very nice gallery. So it's a very interesting project. It's not only about machine learning and AI. It has a number of other services, and of course, it is Cosmos, Azure Storage Account, OpenAI, and machine learning. The key components from this pipeline that we use to train our model are the structure flow and the data acquisition, which I'm going to explain how I reached this point to be able to train a model about prices and how we pre-process the data up to how we need to train it using very easy method of AutoML, especially when you want to reach fast results or when you are just starting with data science and machine learning. What we need is Azure Machine Learning Workspace. It comes with Azure AI Foundry now. You don't need explicitly to create an Azure Machine Learning Workspace unless you want to use an Azure Machine Learning Workspace for your reasons. We need Cosmos DB, blob storage account to store images of the cars. We are using Nest.js, which is a very flexible framework for deploying our applications. You don't need a separate backend in this case of Next.js and our car dataset. If we want to have a look into this architecture slash pipeline, it goes as follows. The user inputs details of the car, of the vehicle, and an image of it. The image is stored in Azure Blob Storage, and the payload of the details of the car, mileage, engine volume, engine power, fuel type, right, are sent to our trained machine learning endpoint. I'm sorry, and the estimation returns back to the user, and of course it is stored in our Cosmos DB. So it is a browsable gallery with the estimated prices, and this future enhancement is already happening. So we're going to have also this bonus enhancement, and then we're going to discuss the final enhancement, which is currently under deployment, under development, I'm sorry. This is a screenshot of what we're going to see. So what what is happening? We're getting the data from Kaggle, okay? We are cleaning the data from Kaggle. We're creating the data set that we are happy with, clean, okay? The data has a certain quality. We are creating an AutoML job. The AutoML job produces the best model, and this best model is deployed into an endpoint, an actual Azure endpoint supported by compute. The endpoint is consumed through REST API via our application that produces the results of the prediction. But let's have a look on this because it's very interesting to see this end to end. So first of all, Kaggle. Kaggle is a community for data scientists, AI enthusiasts, and everyone that really wants to start with the datasets, models, um, communicate with other members, and it's a very um, a rich community where you can find a lot of information and artifacts for your experimentation. I recommend it, I highly recommend it, especially if you're just starting your data science career. When we create our first AI hub, what we are getting is not only this AI hub, but let me show you. This is a hub in Azure AI Foundry. If you go to the resource visualizer, you will discover that you already have machine learning workspace available to you. So you don't need a separate Azure machine learning workspace. You already have it. And if you go to ml.azure.com, you're going to select your workspace and you will find that workspace under the project name. So you need a hub and a project. The project will provide this machine learning workspace for you. So we're working here in this AI Foundry integrated machine learning workspace. Now we have our data from Kaggle. Let's have a look at the data. The data is this CSV file that I found about used car prices. You can see here that the headers are a lot of them, are a lot, and not every header is needed. I don't want all the details. I need something for the demo. And the most important details are here. So I just created my own versioning of this file by removing certain columns and leaving the ones that I want to. I also renamed some of them. Let me show you the correct one. I renamed some of them to engine volume, engine power, transmission, fuel type, and finally estimated price. So we have brand, model, mileage, year of the car, engine volume, engine power, transmission, automatic or manual, fuel type, gas, uh, diesel, and estimated price. Now, you will find that a lot of these Kaggle offer datasets uh, contain some remarks that they need cleaning, they need another pass to make sure that they are they are they have a certain quality, as we said earlier. There are no empty fields, the characters are all in English, and they can be consumed ultimately for a data science project, in our case, a prediction pipeline. So a very simple way to go through this pre-processing stage, as we call it, is use Python. And by using Python, we mean create a very simple file that we go through your rows, find any um, empty field, and remove that specific row. Of course, pre-processing can be much more complex, and for example, there are other projects that you need to, I have been through, and we needed to go through every every field to see whether the characters are correct and so on. In this case, the raw dataset that I found was quite good. It has quite good condition. Only needed some cleaning on empty fields. So I removed all the rows that had empty fields. Now, you are getting a CSV file at the end of the day. The way that we're using it into our machine learning is by utilizing AutoML version 2 of the APIs. And what that means is that we need a file named ML table to accompany this CSV file we have. And if you want to have a look on this ML table file, is this one. Is this ML table definition file in YAML, very similar to YAML format, that defines where is the actual dataset in the CSV in the same folder. Transformations read delimited, and the delimiter is comma, and the encoding is ASCII. Back to our machine learning, what we need to do is just go to automated ML. It's that simple. Automated ML, and we need to start a new automated ML job. So we're clicking here. We need to define a name, first tech 02. The experiment, we're going to create a new experiment, and we're going to name it experiment first 2. No description for us, no need for tags. Next, the task type. The task type is regression. Now, for anyone that doesn't know what regression is and why we're selecting this, I will point you to AI 900 training for the Azure AI fundamentals, where you have everything about types of tasks of machine learning. When we have the need to predict continuous numeric values or anything that is about numeric values, 99% of the time is about regression. The important part of how we're going to provide the data. We need to create our data into the correct format as we discussed earlier. So create a new data asset. So it is first data from Festive Tech. And you can see here that you have these two options. The MLv2 APIs for Azure ML and the MLv1 APIs. We're going to go with the newer version of ML table, meaning we need to have our data, the CSV file with the ML table file as you saw it. So we need to create a data store. We can offer a name here, data first. In a blob storage, you can select your storage account and your blob container. I have it already here with another a previous deployment. Let's add our key. So your machine learning workspace will be able to write into this blob container. Let me get the key. And here we are. Nothing else needed. We're just creating our data store. We haven't uploaded anything yet. So we select our new data set, a data store, and the data set that we just our data store, and we're going to upload our data. You can see here that we need to upload the folder. So it is the folder that contains the ML table and the file. So let me find it. It's here, and I have it here. And this is the folder that contains these two files. If we go to the Explorer, because this is the uploader, if we go to the Explorer, you will see that in this folder we have these two files. Okay, our dataset in CSV format and the ML table that defines the required parameters for API v2 of Azure ML. So yeah, we need this folder. You will get this message, so you know that your two files are just here. Upload and next. We just created our data asset or dataset. Perfect. We just need to select it and next. we are continuing with our AutoML job. The target column is one of the most important configuration parameters. In our case, the target column is what you need me to predict, is the case here. We need you to predict the estimated price. A number of additional configuration settings I want to highlight for you to save a lot of time is keep the normalized root mean square error as primary metric. Do not select all supported models. Just go with light GBM and random forest for now. When you understand a little bit more about algorithms and which one is for which job, you will be able to decide whether you want to use all the supported models or just specific algorithms. In our case, we're going to save a lot of time by selecting these two. The engine will go through the iterations and select the best one out of the specific passes it will have, these trials. So let's have it have 3 trials with 2 concurrent and use 2 maximum nodes from the compute that we're going to create. The maximum score is 0.8, meaning that when it reaches this score, we're happy with it. We have a good scoring for the model, so we can stop the next iterations. We don't need anything better. This is what we are telling it. The experiment timeout needs to be 15 and the iteration timeout also 15. So let's make it a little bit quicker. Validation type, you can leave it to automatic or train validation split, where our engine will split 10% to validate the data for the model. Next. Now the compute type. You can either go with serverless and select instances 1, 2, 3, 4, or go with compute instance. In my case, I have already a compute instance prepared, or you can create this new and select a compute instance. For our case, you don't need something very strong. This model DS3 V2 is fine. For more advanced models, you will also have the capability to select GPUs, right? But we're good with this one. Next. And we're ready to run our job. What will happen here? Our data set is going to be consumed by our Docker image that will be installed into this machine, into this compute, and it will start the iterations, this repetitive process to find the better connection between the estimated price and the values that the columns contain. What is the relationship? Is a repetitive question that will be asked there in the numbers, of course, language. When the model reaches the score of 0.8, it will be satisfied as we have configured and everything will stop and we will have our model ready for deployment. I explained it in very simple language, but I believe it is a language that everyone understands. And I know that our audience is not only data scientists, we have AI enthusiasts, architects, engineers, and many talented people that really want to learn, just like me. And we're submitting. Now, if you get an error here or you see that the user interface is stuck or is turning, don't worry, just refresh the page. You will get the message that the machine has started here, the compute instance has started, and because our configuration parameters are quite, yeah, it failed because I think I'm out of quota. I have already run it. Or let me start the compute and retry. Um, we have prepared our case to be fast. So let me start the compute and retry the experiment. But we don't care because everything is ready and we're going to see it in action. I just want to be able to show you how to do it. Be careful with quotas because machine learning uh, is falling under the quotas limitation of your Azure subscription. So in case you see you're not getting there, you need to open a support ticket and ask for more quotas. The same stands for GPUs, so be careful there to work with that. Let's restart this, edit and submit, and resubmit it. Yeah, we have to wait for the compute to be ready. It is starting. Let's give it a moment. Now, while this thing is starting, let's see a little bit uh, on our application what's going on. So let me show you the application. This is a very nice application indeed. Next.js is using React formats, and you can create very beautiful user interfaces. What we have here is our frontend, and in Next.js, as I said, there is no backend. There is just a folder named APIs where you can utilize the next router or router that plays the role of your backend and is responsible for routing your requests when where they need to be routed. A folder for each separate route, and the name is the same. I really like Next.js, especially for these quick and fast demos, but it's also a very powerful framework language for your web applications. This is our user interface. We are also utilizing a beautiful gallery with Cosmos DB on the backend and Azure Blob Storage for the photos. The, the estimated price is created on the fly when you are providing the estimator details. So you need to select the brand, the model, the year of the car, the mileage, the volume of the engine, the power of the engine, the fuel and the transmission. Quite important factors that define the price of a car. Okay, but here is the catch. In the third version that is under development, we will offer the ability to add 4 pictures of the car, so an AI vision will be able to understand the condition of the car. And this is also an important factor. So if the car is a little bit more used, a little bit more into an accident or something is scratched or whatever, it will affect the price. In this version, we just need to upload one photo, and let's go find some photo of cars. I have already uploaded 2, so let me find something that is not there. Let's see this one. I don't remember what type of brand is, but I will add something. I think this is an Opel, but I'm not sure. Let's add it as a Mazda or something. RX, I don't know, RX1. It is 2016. And the mileage of this one is 120,000 kilometers. The engine volume is quite strong, and the engine power is also something really strong. Fuel is diesel, and the transmission is manual, or let's say auto. It is a sports car. So while we're waiting the other deployment to conclude, we can get our estimate. So let's see the user experience here. And this is the estimation. You can see here that it is probably very close to the actual reality of this type of car, 23,400 uh, in dollars. Very nice. Thank you very much. And now you can also browse this car in our gallery. And what else can we get here? This AI summary. Our separate OpenAI model is able to create, this is a mini model, is able to create a short summary with details about the market of this specific model and informs the buyer about the details that make this car unique and why they may consider to buy it or not. Okay, very important. This is the user experience. Let's go back to the engineering part. Our compute is running. So in our jobs, we should probably go back here and try to resubmit our job. It won't take that long. And it is submitted. You will see very soon here the starting, and you need to be a little bit patient when you're working with machine learning experiments. Now, the more data you have, the more time it will take, okay? And the more models you want to explore, also the more time it will take. So you need to balance these options before you submit your job. Also, be very careful with your quotas and your compute. You can go with serverless, or you can create an instance, or even use Kubernetes. In our case, we're having a demo, so I'm just creating an instance just to be a little bit faster here. So what's happening now? The job is running, and you can see here that it's using our dataset, as we said, and here is the experiment. So the job goes under this experiment type of artifact, and you can see what's going on. This job produces child jobs that are the actually cycles of iterations of this relationship discovery by the model, right? How this uh, regression, the estimated price that we are looking for is affected by all the other values that are within the CSV, and it's retraining. It's retraining. And this, I'm sorry, in this iteration, it will produce the model that has the better understanding of this relationship. So when it is offered new data, it will able to make the correct prediction. Okay. So here are the child jobs. We are already in a child job, so yes. So under this experiment, you will find your job. Let it refresh. A lot of information will take some time to be available to you, and you will see here that when this job finishes, we will be able, this is the parent job, yes, we will be able to see the outputs, other jobs that are running. uh, uh, yes, you can see here, for example, we have already two child jobs that have been completed, and when they finalize, you will be able to see, we will be able to see more data when the experiment is done. So let it, let's wait for it. uh, Let me show you another completed job to have a better understanding. So let's see this car trainer. That had, you can see here that model is produced. Okay, the live GBM with the metrics. Okay, when everything is done, you will be able to find a lot of details about the algorithm used, how the metrics occurred, and how the model reached uh, the finalization, the conclusion, okay, based of course on our configuration settings. Again, I want to highlight AI 900 is a very interesting training collection. So if you're just starting, or you are just introduced to Azure AI and Azure in general, it's a very good collection of courses, modules, and knowledge paths, learning paths. So I'm highly recommending to go and check it out. So our job is still running and we will have soon our best model. A little bit on our infrastructure. So let's have a look on our infrastructure. We are not Dockerizing this application. We're going to build it as a web app. So while we're waiting this to finalize, let's build our application. So a number of options here. You can Dockerize it. You can build it as a static web app or an Azure web app. If you go with static web apps, you need to be very careful of how you define the relationship of Next.js with the hosting environment of static web apps. In the Azure Web Apps case, it is the easier out of the three. Docker is no question the best for production. Static web apps is the best for cost. We're going to go with Azure Web Apps. So this is the only command you need. You need to have pre-created the web app in your um, resource group, and this is the name that we're going to give to our Azure Web App. So let's create it. A new web app. I don't remember if I have it ready, so let's have a look. A new web app. Yes, it's here. So let's deploy. One command, that simple. The source path. You need to be able to zip your code. Produce a zip file with your code, but you don't need to add everything. So let's see what we need to have in our web app. You need to go to the root directory and select everything except GitHub, screenshots, environment variables, readme files, and MD files in general, but everything about packages, so the environment will know what packages to install, and everything that has to do with Next.js. So I think I have selected everything. Node modules, no need to add them. Neither this one, neither this one. Yes, we are very good to go. I will use 7-zip this time to create our archive of zip format in one folder above, and it is web app file. You need to be able to check out this here. You need to be careful to check out this here that is zip format, and okay. If you want to make sure that your web app will be deployed, you will just need to run npm run build. It will build a local build on the machine, on your workstation, and if anything goes wrong, you will be informed about it. So we have our uh, zip ready, our web app ready. All we'll need is to select the source path as it says here. So I need to go to directories back if I remember correctly. This is correct. Let's try it. What we have to lose. I think I'm in the correct path. Yes, I think this is the correct. No, it's not. Other resource group is not found. Okay. Oh, it's the another name of the web app. So yes, this is the correct name. Festive web cars. Festive web cars. Okay, let me copy this. Festive web cars one. It's not, but I have my festive car. Yes, festive web cars. Yes. Now this web app is when you try to create it is type code, and you just need to offer an application service plan, which for this application could be even the basic one. But in order to have it fast, I have selected a premium plan. Let's return to our machine learning to see how that goes. And yes, the job is completed. And you can see here that the best model is MaxAB Scalar Random Forest. Usually it will be this one, especially if you select these two that I offered. So what we need to do now, our job is completed. Our model is ready, is created in Azure Machine Learning. How we can utilize it? Hmm? How we can utilize it? We need to deploy it. So there are two stages here. We need to select deploy into a real-time endpoint, and we're out of quota. I'm going to delete something else, or I'm going to stop the, let me see. No quota enough for this one. Let me see if I can have one instance. Yes, with one instance we're good to go. Yeah, it's a very small model. So we need an endpoint here, fastech 002, and the deployment name, fastech 002 dip. And that's it. The instance count is for the deployment, how many instances of the compute is going to use. Microsoft recommends at least 3, but we are out of quota at this point in time because there are other models ready waiting for us. I don't know if, I don't think we can select this one. Let's see. Ah, okay. It is a specific, uh, it's the specific sizes. Okay, okay. We can go with an E2. So not very good. Deploy. Pay attention to the deployment name. I will show you something that's very important. So what's going on right now? We got our model, right? And we want to publish it in a REST API endpoint. So our application, when someone clicks the button to get an estimation, the payload is sent to that REST API endpoint, and the model has already been there, it's created, and it can perform estimations. So through the REST API, and of course, our specific our specific call to this model via our code, the payload is sent to the model understands the payload, so you need to be careful how to construct the payload, and everything is offered by machine learning. It is returning our estimation. And what I mean it is offered when the deployment ends, deployment is created, we need to wait just a few minutes to have the endpoint ready. So give it a moment. You will see here this menu will be enriched with more selections. Right now the deployment is ready and it is ready to create the endpoint. And this is actually Azure resources. Let's have a look. In our resource group, this is the resource group. Observe here. Observe these icons. These are the previous one that I created. I have already two. I'm creating another one. So these are the deployments and the endpoints. So we have two types of resources created right now. Deployment. This one is the one we have. Okay. Deployment. Where is our deployment? Let me make this a little bit bigger. It's our endpoint festive. Festech is the endpoint. We're looking for the deployment. Where is it? Festech 002 dep. This is the deployment. Let's click on it and see what's going on. Observe this amazing feature, scaling. If you're going to production and you suddenly understand that you are getting a lot of requests, you can create auto scaling for your endpoint. So the deployment that supports the endpoint will be able to auto scale based on a metric. And you can start working with your scaling conditions. Number one information, very important. Also, metrics visibility through the deployment. And secondly, second observation, the actual endpoint. So you have deployment and endpoint, right? And our endpoint is, I think, the best tech, if I remember correctly. This is our endpoint, okay? It is creating by default system assigned identity with specific roles. Let's see the roles. Why? Why it has these roles? Because it needs to write the information of the metrics into the machine learning workspace so the deployment and everything is visible to us, and storage blob data reader into this storage account to be able to read information from our storage account that has our data set and other information when it was trained. Another information I want to show you also is that you can download the configuration. Yes, in the properties here you can get the resource. Yes, the deployments, and here you can see traffic 100%. You can also apply split traffic configurations. This can happen, I'm sorry, through your machine learning. Okay. In our case, we will have 100 traffic allocation, 100% traffic allocations, but we have the capability to create this split traffic if we want to. So imagine the possibilities and the capabilities that you are offered through a simple click ops pipeline offered by automated machine learning. You don't need to go through the very complex but also powerful pipeline that we are creating in machine learning. Let me show you quickly a pipeline. So here is a sample of a pipeline. Okay, you can do amazing stuff here, but when you're just starting, you're exploring, you want to learn, automated machine learning provides you everything you want in a production level, enterprise level um, deployment to play around, learn, and create your resources. So let's see how our model is doing with models. Our model is the Festic Tech Job. No, let's see here. I don't remember the name. Fast Tech. Yes, this is the deployment. You will see here the menu that will get enriched, and we will get also the code for specific frameworks that can make it work through our applications. Here is the Swagger also. Okay, not ready. And the rested point, which you will find it here in my environment variables from another model that's already there. AI endpoint URL, and it is slash score. Okay, the application is building, the web app is building, and our model is already under creation. Let's see another model to understand what's going on. You can see here the menu. You can test it live here. Here are the columns, right? You can just enter information, data, and test the model for to see if it is uh, representing reality, first of all, or if it is working uh, as well. Okay, consume is the most important menu here because you don't know or you're not able yet to read the documentation and understand how to create your code to consume the model. So for JavaScript is this code you need to implement. For Python is this code you need to implement. For C Sharp is this one, and for JSON there's nothing here because you have it here in the test. This is the one for JSON. Monitoring to actually observe the request, the latency, and what's going on with your model and logs as well, ARM and online deployment logs. And this is still creating. It will be ready in a few. Let's see if our web app is ready as well. This failed because the site failed to start. Yes, failed to start the allocated time. Yeah, I think there was a parameter uh, that needs to be added. The clean one. Let's retry. I think the second time is a charm, but it doesn't matter because you have already seen the user experience and we don't need to start, troubleshooting. Also, you will find in my information, let me show you. I'm Konstantinos Masades. Thank you for being here with me today. I will return to the deployment to see if we can catch a little bit more details. I think we saw a lot in this 60 minutes. I think we're not even 60 minutes, 45 minutes. Scan the QR and you will find information about the blog, the website, my LinkedIn profile, and uh, YouTube videos that are on the same um, approaches, mostly demos, mostly hands-on demos. I'm an Azure MVP in AI and Azure integration. In my blog, you will find this specific deployment, cloudblogger.eu, and here it is, make your application smarter, powerful machine learning demo. There is also the accompanying GitHub with all the code that you just saw. So please ping me if you see something that you want to make better. I'm very open to collaboration, and I really want to help you or get things to the next level. This code doesn't have yet the OpenAI summarization that you just saw, but it will be updated very soon. Also, I want to work on the other development phase of AI vision. It's a very nice idea, and we will take this application to the next level. Because imagine, you know, seeing the car by an AI model trained correctly to understand deficiencies, defects of the appearance of the car, and decide how this affects the price. This is a very important step in such an application for used cars. While our time is running out, let's have a quick look in our machine learning. Yes, the deployment has concluded and the endpoint is ready. So let me refresh here. Yes, you see the traffic allocation is 100%. I can edit. Okay. We can um, add another deployment or update traffic to use 50% and then another deployment use another 50% so you can, you know, play around, user acceptance testing, amazing capabilities here. The testing, as I said earlier, and the consume that we already saw, you can just grab the code and add it into your application. Very important SOS in your app. So yes, you have the code, you have everything, and you just need the correct environment variables uh, to communicate with each service. There is one important, however, step where you need to pay attention. In the estimate, there is a hard-coded value here. So it is the deployment of the endpoint. It is not added in the environment variables, it's hard-coded in the code. Be careful with this. If your application is failing, most likely will be this variable. You need to take it from the machine learning workspace or from the Azure portal to get the deployment of the endpoint, the deployment name, as is, as you can see it here, just the name of it, and add it in your code. Here you can see the code that we took from the machine learning. Okay, we just uh, adjusting it for Next.js since it is a JavaScript family of um, framework. So let's give it a moment here to see how this will go. Let me see here if we need to do something. Also in my web, you will find this small detail that is also important when you are deploying. You need to add this startup command, npm start, okay? And this goes in your web app. There is a startup command setting. So here, yes, this is here. This one, npm start, okay? The stack is Node, so you can change to Node 22 and 24. It's up to you because it's Node 20 is retiring. If this continues to fail, maybe switching to Windows will be better. Let me have a quick look here. Node 20, maybe we need also the value, compress the whole, including node modules. This is a detail that I forgot. You see, when you're working with a lot of frameworks, sometimes some details are different between each other. In this case, we need to include the node modules in the zip file. So let's do this and have a final retry. So this one, including node modules, and this one, and this one, and this one, and this one, and this one. I think I have everything. We don't need the GitHub, neither the local. Yes, we're good to go. Let's do this. 7-zip, add to archive. One directory up, web app file, one. Do it. So you need to include the node modules. Yes. Okay. You see, when you keeping nodes through your blog, everything gets easier. And when you fall into a dead end, something you forgot, something, because one brain cannot remember everything about everything. It's good to keep notes, and this blog is quite useful, especially for me, and I know it's for you guys. So big thanks to every visitor there. Okay, let's break this. And retry. I hope it's done. Yeah, it's done. And retry with web app file 1. And it will clean it already, so we have this one. Deploying from local path, warming up. Usually it doesn't take that long, so if everything checks out now, it will be deployed very soon. Let's add also the command in our npm start and apply. And we need to add the environment variables. This is very important. So you need to go here, and if you're not using a key vault integration, you need to add every environment variable from your env local to this environment variables setting. So let's do it. Yeah, we know. apply, add another one. Yeah, I could do it through VS Code and upload, local settings. But sometimes, especially in demos, I prefer to have absolute control with the mouse and the keyboard. VS Code, why I'm doing this? VS Code has a lot of configurations, a lot of users, and sometimes into my um, hastiness, I may make a mistake. The AI endpoint URL is our endpoint of machine learning, our machine learning endpoint that it will create the predictions for us, the most important part of the application integration with machine learning. It's the outcome, right, of our experiment slash job in machine learning. Remember, in AI Foundry, you don't need a separate machine learning workspace, you already have it. Also, you need the API key. Key, apply, and we need the Cosmos connection string. Let's add the connection string with Cosmos. It's a very long string. You need to be careful, don't miss it. Control C, Control V, apply. Add the other one, which is card data unused. Card data used, database name and container name. So we have created, I will show you that also. Card data. We have created an Azure Cosmos NoSQL DB with a container named used. Azure Cosmos container name used. Their name, great. And the final one is this one that adds really good value into our deployment with OpenAI. Let's hit and apply here. Confirm. The OpenAI is not that important in the deployment of the web app. Okay, perfect. You can see it is a Linux application. I have selected preview. It is code, right? No need for container right now. Of course, you can containerize the application if needed. And it is of Node 20. Yeah, it's ready. You see that I hit that, and we can start working with that. So that's it. I think this one, if it, yes, it completed successfully. Second time is a charm. No, I think it has to do with the node modules directory that it is needed in our case. Don't forget the npm start command in the configuration. So, yes, if you have any questions, guys, don't hesitate to ping me. Again, you will find everything about me into this QR code, and you will find me also in LinkedIn, of course, which I'm active. Kindly visit my cloudblogger.eu website to find more information about this application, this deployment, and GitHub. If you want to get a little bit of a deeper view and you want to clone the repo and you want to take it to the next level, I'm already into this development stage where we will add AI vision to predict the price of a used car based also on its visual condition. I hope you really liked it. I really hope it is an interesting session. More interesting sessions throughout December from Festive Tech Calendar. And before I say goodbye, I want to highlight the efforts of Festive Tech Calendar to support the Beatson Cancer Charity. Uh, you can contribute whatever is your capacity to help others and to provide some uh, an open heart, let's say, or your helping hand with this small but valuable contribution and initiative from Festive Tech Calendar for 2025. I hope you have great holidays. Be healthy, be strong, be safe, and see you very soon. Bye bye, everyone.